Today's lesson involves ratios and proportions. Ratios and proportions will be very important in the coming days when we learn about similar triangles. But in today's lesson we will test to see whether two ratios are equal, and we will solve proportions. And by the end of the lesson you will be able to tell or explain how to test whether two ratios are equal, and you will be able to explain how to solve a proportion. Let's look at the definitions. A ratio, if you'll remember, is simply a comparison of two numbers by division. For example, if we have the ratio 3:4 written as the fraction 3/4, when we do the actual dividing of 3 by 4, we get 75 hundredths, or 0.75. This ratio is comparing some quantity 3 to another quantity 4. A proportion, on the other hand, is simply two ratios that are equal. For example, if we have the ratio 6:4, we can divide the numerator and the denominator both by 2 to simplify, and we get 3/2. So those two ratios are equal, therefore they form a proportion. Now, if two ratios are equal, then the cross products will also be equal. What I mean by the cross products is simply the numerator of one times the denominator of the other. And when we do that, on this example, A to B is equal to C to D, then A times D is equal to B times C. An example is seen in the ratios 6:4 and 3:2. If we do the cross product of 6 times 2, that equals 12, and the other cross product of 4 times 3, that also equals 12, and 12 equals 12. So the cross products are equal, therefore those two ratios are a proportion. So let's look at some examples. Let's first, in example 1, test to see whether a pair of ratios are equal, or whether they are a proportion. So in example 1a, we have the ratios 4:6 and 12:16. To test whether they are a proportion, we will do the cross product of 4 times 16, and that's equal to 64. And then the cross product of 6 times 12, which equals 72. Now we know that those two numbers are not equal, therefore these two ratios do not form a proportion. In example 1b, we have the ratio 3:5 and the ratio 6:10. And we can test to see whether they are a proportion by doing the cross multiplication of 3 times 10, which is 30, and the cross multiplication of 5 times 6, which is also 30, and 30 equals 30, therefore these two ratios form a proportion. Now we can use this idea of the cross products being equal when two ratios form a proportion to solve proportions. So let's look at examples 1 and 2 here, or 2 and 3 rather. In example 2, we have the proportion 7.8 to A is equal to 4 to 3.82. Now we're looking for the value of A that will make these two ratios a proportion. So by solving the proportion, we find that value of A. So the first step is to cross multiply. So we'll cross multiply A times 4, which gives us 4A, and then we'll do the cross multiplication of 7.8 times 3.82, which gives us 29.796. Now that gives us a simple one-step equation to solve for A. And to solve for A, we'll divide by 4, and we get A equals 7.449. In other words, for these two ratios to be a proportion, then A must be 7.449. Now example 3. We want to find the value of X so that these two ratios are a proportion. In other words, the value of X that will make the two ratios equal. So first we'll do the cross multiplication of 3 or negative 3 times X, and then we'll cross multiply 7 times X plus 2, which gives us 7X plus 14. Now to solve for X, we'll subtract 7X from both sides of the equation, and that will give us a negative 10X equals 14, and then we'll divide by negative 10, and we get X equals a negative 1.4, or a negative 1 4/10. So X must be a negative 1.4 for these two ratios to form a proportion. Let's look at a couple of more examples. Example 4. Let's solve for X. Let's solve the proportion. So first we'll cross multiply 5 times X, and then that will equal the cross multiplication of 3 times X plus 6, which is 3X plus 18. Then to solve for X, we'll subtract 3X from both sides, and that gives us 2X equals 18, and therefore X equals 9. Then we have example 5. Still using the cross multiplication technique to solve the proportion. So first we'll multiply X minus 2 times 4, which gives us 4X minus 8, and then we'll cross multiply 2 times X plus 6, which gives us 2X plus 12. To solve for X, we'll first subtract 2X from both sides of the equal sign. That gives us 2X minus 8 equals 12. Then by adding 8 to both sides of the equation, that gives us 2X equals 20. And then we solve for X by dividing by 2, and therefore X equals 10. Proportions are a very useful mathematical tool to solve many real-world problems. And that's what the next few examples will show. So in this example number 6, we have a word problem in which we're told that Josephina sells helium balloons. She charges $9 for 12 balloons, and we're asked to find how much she would charge for 50 balloons if she continued charging at that same rate of $9 for 12 balloons. Now, one key to solving word problem proportions is to make sure we understand what the ratios are. So it's always a good idea to write the ratio in words first. So in this problem, we see that dollars are being compared to balloons. So our ratio will be dollars to balloons. And we're given one ratio of 9 to 12. So $9 for 12 balloons. Then we're given some more information about how many balloons she aims to sell and how much she would charge for those 50 balloons. Well, since balloons in our word ratio is in the denominator, we will place the 50 also in the denominator. And we will use a variable in the numerator because we're looking for how much she will charge. So to solve this proportion, we will cross multiply 12 times C, which will then equal 9 times 50, or 450. Then we will divide by 12, and we get C, or the amount that she charges, is $37.50 for 50 balloons. In example 7, the problem is a photo machine copied 50 pages in 1.5 minutes. And if it continued to copy at that same rate, how long will the machine take to make 90 copies? Well, again, we will write the ratio in words, and we see that we are comparing pages to minutes. So we'll write the ratio this way: pages over minutes. And we're told that the first ratio is 50 pages to 1.5 minutes. And we want to write another ratio using the information we have. And we're told that the machine will copy 90 pages in all, and we want to find out how many minutes it will take. So the 90 pages goes in the numerator, and the variable, let's say m, is in the denominator. So we have a proportion that we will solve by cross-multiplying. So 50 times m will equal 1.5 times 90, which is 135. Then solve for m, we'll divide by 50, and we get that m, or the number of minutes, is 2.7. And the final example is regarding a recent school bond issue in which 3 out of every 4 votes were in favor of the bond. A total of 2,550 people voted against the bond, however, and we want to find out how many voted for the bond. So again, we will write a ratio in words, and the ratio that we have explicitly in the problem is votes total to the number in favor, or the number in favor to votes total. And this is how I wrote it: those in favor to the total number of votes cast. And that was 3 out of every 4. But in the problem, we're told that 2,550 voted against, and what we want and don't know is how many voted in favor. So we need to find out how many voted in favor. Well, notice the original ratio, 3 to 4. If 3 out of 4 voted against, or in favor, rather, then 1 out of 4 voted against. So that gives us a new ratio. We can now write the ratio of those for and those against, or 3 to 1. Because now we know that 2,550 voted against, that will go in the denominator, and we're looking for x, which is in the numerator. And we'll solve by cross-multiplying, and we get x equals 7,650 votes in favor. Now you have enough information, enough examples to complete the practice assignment if you'll just follow the examples and do your best.